Hello everyone, my name is Aldo. I'm here as one of lecturer of robotics and artificial intelligence in Faculty of Advanced Technology and Multidiscipline, University of Atlanta. I want to present short academic course series for a sustainable energy and green technology application SEGTA 2024 event. My course is a multicopter drone introduction, principle, and implementation on agriculture. And what we learn in this course, first we will talk about drone or UAV, and we focus particularly about a multi-rotor, the flying mechanism and construction of the multi-rotor, how it can fly, and the physics behind it, and the propulsion system, or system, battery, flight controller and sensor, software and platform, and the last is agriculture application. Okay, first we want to talk about drone. What is a drone? A drone is an unmanned aircraft. Drones are more formally known as unmanned aerial vehicle or unmanned aircraft system. There are two words meaning for drone than a melody or a monotonous sustained word. So a buzzing word that kind of like a drone. And sometimes many common people very confused between drone and UAV. Still in the confusion between drone and UAV, there are several terms and abbreviations that commonly used in aviation. Yeah, so we know UAV, UAS. UAV is unmanned aircraft vehicle. UAS is unmanned aircraft system. RPA is remotely piloted aircraft. And maybe you most commonly hear the term drone used by the media and military, and UAV used most often by the FAA. But actually, the words drone and UAV mean the same thing and can be used interchangeably. Both are aerial devices that can fly with a human remotely controlling them, or in the most advanced cases, it can fly by themselves without any human intervention. There are rotorcraft system, fixed wing system, hybrid system, biomimetic system that articulate the living things, a lighter than air system like a balloon. Yeah. There are so many drones or UAV. But in this presentation, I will focus on the drones. I mean, the multicopter. Why I why I keep saying drones? Because the popular perception of drone is a multi-rotor multicopter. Yeah. So we will focus on the multi-rotor or multicopter. While the commonly known helicopter has one rotor, the multi-rotor is a one unique kind of aircraft that is equipped with two or more motors, not only one, but two or more motors. In this course, we will introduce you to some popular types of multi-rotor and explore the pros and cons of this configuration, the principle, and also the application in the end. And it's really known with its practicability, maneuverability, because it's become popular as toys, photography, and for racing, and for recreational purposes. But also, this aerial robotics platform is very useful for any kind of custom task. Okay, and the multicopter, there are so many, and we will discuss it by one. Bicopter could be the cheapest multicopter configuration to build among all because it only uses two motor and two servos. But it also most difficult platform to stabilize in flight. It has least lifting power given that it has a least lifting power given that the fact that it only has two motor and also need two servo. And the tricopter, uh, based on the name, a tricopter, it has three rotor and typically in Y shape, sometimes in T shape. It has a 120 degree, apart between the leg, and on the back it has a servo to tilt the rotor, so it can stabilize. That's why it can stabilize. And next is the most popular configuration is a quadcopter that has four motors mounted on a symmetric frame, and each arm typically has a 90 degree apart for the X4 config. and plus config. So in the right is a plus config, on the left is X config. Two motor rotate clockwise and counterclockwise, and the other rotate counterclockwise. Yeah, so there are clockwise and counterclockwise to create opposite force to stay balanced. Yeah, so there are X and plus, and the X config is more popular as you can keep the propeller out of the camera view, yeah, because you can put the camera in the front, and it's really nice to have the view, yeah, because it's not covered by the rotor itself. And how quadcopter fly? Yeah, well, the propeller spins, yeah, push air down, and similar to helicopter, pushing the air down is the action in Newton's third law of motion. Reaction is a force called lift, yeah, and which pushes the quadcopter up. Each of the propeller will create a lift, and the total lift for the quadcopter will be the sum of the four propeller. So it to make it fly, the total force of the lift must be stronger than the gravity itself. Uh, so that's why it can fly. And how it movement? Yeah, the lateral movement occurs by varying the speed of the propellers, increasing the speed of the two propellers on the one side, so for example on the back, and decreasing the speed of the two propeller on the other side creates uneven amount of lift on the two sides. And the lift, yeah, the uneven lift is created on the side with the faster spinning propellers is greater than the lift created on the opposite side. The result is that the quadcopter moves the direction of the side while less lift is created. So, for example, yeah, this is the less lift, yeah, it will move on the right. And how quadcopter maneuver? Yeah. So the variation between the rotor, yeah, we know that if we want to move down, just lower the speed, higher the speed if you want to move up, move forward and move backward, just varying the front and the back rotor. Yeah, roll control, it's the same. Yeah, only left and right uh, motor. Yeah, and the yaw control, it is interesting because we have to make a higher speed on the two rotor blade. Yeah, and higher speed on this diagonal on two rotor rotate right. Why it can yawing or it can rotate? Because the inertia of the motor. And how do multicopter stabilize? Usually because it has a sensor, usually IMU, inertial measurement unit sensor, that consists in the drone, in the multicopter. So usually IMU consists of following sensors: three-axis accelerometer, three-axis gyroscope, three-axis magnetometer. Yeah, so the accelerometer to measure acceleration along its axis, gyroscope measure the rotational velocity around its axis, yeah, the rotational velocity, and the magnetometer measure the local magnetic field, so it can distinguish the what the drone heading to. And this is the airframe that usually used in a multicopter. There are quad, I already mentioned it before. There are hexacopter, hexa using six rotor, and there are also coaxial configuration that I will explain it on the next slide. Hexa Y, hexa IY, yeah, octocopter using X configuration, but it has 8 motors, and also octocopter with this kind of configuration. And so there are many configurations because it depends on the project or the application of the drone. It also depends on the stability that you want to achieve more motor, more stable. Yeah. If you want to achieve more motor, if you want to achieve a more stable, you have to put more motor. And for security, more motor means more secure. Since the system can manage if one of a rotor fails, it can stabilize by centering the thrust system. So this is the example of coaxial configuration. Yeah. There are two rotors that put on the same axis, up and down. And yeah, we have a closer look on the coaxial motor arrangement. Advantage of the coaxial motor arrangement: first is a redundancy for security. If one motor fails, the aircraft can still maintain balance in the air and allow it to land safely. And it's also saves space, and using coaxial motor can create a better design for fall level. And the disadvantage is the power efficiency. Because some of 1 to 10% to 20% loss in power efficiency, because uh, the bottom motor is just turning already sped up air, so it's losing efficiency there. And propellers can get caught by obstacle more easily as pilot could oversee them. Because the propellers are located above and below the arms, they are hard to hide from the camera view. That is the disadvantage as well. So it's not ideal for camera view. And this is the multicopter frame. And this is the example of multicopter frame. Common material that used is carbon fiber, epoxy fiber, ABS plastic, and sometimes they are using aluminum as well. And I think the best you can use is the carbon fiber, but you have to sacrifice the price of the carbon fiber. And this is the frame size. The frame size is, I think, very important. The size will be parameter to decide the proper size as well. Bigger size has bigger motor, bigger battery, and heavier lid. So how we determine the size? So we can determine the size with the diagonal length here. We can measure the diagonal length, the diagonal distance, which is the length between the axis of rotor diagonally. So this is the frame size. You can see it on the table that the bigger frame size, bigger propeller, bigger motor, and bigger battery as well. And next we moved on the basic about battery to for drone. The basic about lithium polymer battery. Usually drone using a lithium polymer battery because it commonly used because its C rating. It can draw so huge current. So huge current charge, and it has a high energy density, and we will discuss about it. So in the drone, what information that you have to know about battery is a battery voltage and cell count. So the cell count, so this is the example, the diagram. The cell 1, cell 2, cell 3, cell 4. So it is a 4-cell lithium polymer, and this is the arrangement for 2 cell. Lithium battery access in a cell. Each cell has 3.7 volt. If higher voltage is required, this cell can be connected in series for form a single battery. And we don't normally refer to battery voltage, so we call it cell. So when you are into the drone, you are on the drone community, they usually call it cell, not the voltage. And this is the little battery capacity and size. For example, you have a 1013 milliampere hour lead. It will take an hour to be complete discharge if you draw a constant 1.3 ampere current from it. And if you draw 2.6 ampere, the duration would be half. So that's the calculation. If you draw, for example, all of the motors draw 39 ampere of the current non-stop with 1300 milliampere LiPo, you only get 1.3 per 339. It's about 1 per 30 of an hour. It's only 2 minutes. And the milliampere is basically an indication of how current you can draw from the battery for an hour until it's empty. That is the key point. And still on the little battery, increasing your battery capacity might give you a longer flight time, but it will also get heavier in weight and larger in physical size. As the battery gets larger, the increase in flight time becomes ineffective. Eventually, it will reach a point where it just doesn't gain any more flight time with a bigger battery. Yeah, so when you push the battery bigger, the size bigger, and you will not get a better flight time. It will stack. It will stuck on the some flight time. You have to get a more density battery, I think. And when it's time to land, so we have the graph here. This is the full charge, and the 30% to 40% is the area where you have to worry, where you have to put attention on your drones, yeah. And because after the 5%, yeah, about 3.5 or 3.6 volt per cell, it will drop. Yeah, it will drop. Wow. So it will drop to create zero voltage. Yeah, maybe it will create a zero voltage, and it's very dangerous for the aircraft. Yeah, because if it pointing down like this, yeah, the voltage will be drops and the system will shut down, yeah, and it will fall. Yeah, the drone will fall. And we move to electric propulsion system for aerial robotics. Brazos DC motor is a synchronous motor using a direct current electric power supply. However, it runs like AC motor, but because BLDC gets three-phase voltage source from ESC, so that runs on DC voltage. Yeah, actually, it has a three-phase like AC motor, but the source is a DC voltage with a motor controller. And this is the Brussels DC motor. You can see it on the picture. Actually, this motor is commonly used on every area, in many area. Uh, it used for computer hard drive, electric vehicle, electric bicycle, industrial robot, washing machine, blowing fan, and so on. Yeah, there are so many applications of Brussels DC motor. Oh, sorry, the wider stator has a larger moment of inertia. That's why wider stator now is very popular. But the advantage of wider motor is better cooling as well, thanks to larger surface area. The wider stator also allow a large bearing to be fit. So large bearing are better efficiency, smoothness, and longevity. But the taller stator give you instant acceleration because the inertia is low. And the BLDC motor, we will hear kV on the BLDC motor. So the BLDC motor kV is very important because higher kV motor have shorter winding that does lower resistance. It lowers maximum voltage rating and increases the current draw for the motor and propeller. And generally speaking, the heavier multicopter usually have lower kV motor. Lighter quadcopter usually using high kV motor. Yeah, so that's why it's connected. Yeah, a revolution per volt. Yeah, when you found 850 kV, you will rotate the motor 850 RPM per volt. But with the lower kV motor, for example, this one has 29 kV. Yeah, 29 kV, you will get 29 kilo RPM per volt. And this is the motor thrust start. Yeah. This is very important when you are designing a multicopter. You will take a look on this, yeah, because it will give you the ampere information. Yeah. It will be very useful when you are deciding what kind of battery, and when you are deciding the maximum takeoff weight of the multicopter. So how to choose the motor? First, you have to know the total weight and the frame size. The total weight of the quadcopter should include all the components, yeah, the flight controller, ESC, motors, propeller, RX, video transmitter, antenna, LiPo battery, GoPro, the camera, and so on. You have to put that on the scale and you write down the weight, and that is the very useful information to uh, decide what is the motor or what is the battery. Yeah, thus thrust produced by all motor is at least double of the total weight of the quadcopter. That is the key when you are when you are building a multicopter. And this is the electronic speed controller, or ESC, um, usually using a MOSFET electronics here, and that is like a switching, and to make the three phase will work uh, each point, and creating the rotating magnetic field so that the motor will rotate. Yeah. The higher frequency of the clicker of ASC goes through the 6 interval. The higher the speed of the motor will be the higher the speed. And this is the electronic speed controller as well. So you have three things that tend to increase your current. First is a higher motor kV. Yeah. When you have higher motor kV, you have to uh, put the ESC that follows the current of the motor. Yeah. So the larger motor size will be creating higher ampere. Yeah. And heavier propellers also draw higher current as well. The key point here to deciding electronic speed control is the current that draw on one rotor or one motor. And how we connect the motor? Yeah, so we just connect it because it has a three connection. And how to make it rotate clockwise and counterclockwise, or how to make it rotate on reverse. Yeah, so you have to change two of three cable here. So like in this diagram, so it will rotate on the opposite direction. And the proper direction, we have to take a look because the propeller usually has some specific direction to use. There are two motor spin, clockwise and counterclockwise, and don't forget to see on the propeller which one is fit on the direction, on the right direction. And the propeller size, the length of propeller is the diameter of the disc. Yes, for example, when it's rotating, it's creating a semicircular area or the disc area that make it spinning. That is the length of the propeller. The pitch can be defined as the travel distance of one single prop rotation. For example, like a screw, yeah, you can imagine it like the screw. One rotation, how long it will move axially. Yeah. That is the pitch. The multicopter can work if there is a flight controller. In the flight control, there are some sensors like accelerometer, gyroscope, barometer, compass, GPS. IMU we already discussed, yeah, and there is a barometer for knowing what is the pressure of the air, the compass to know what the drone heading to, and GPS to know where the exact location, latitude of longitude of the drones. Yeah. This is the Arduino platform of the multicopter. This is the recommendation for you to learn multicopter, but not only for a user, but also as the developer. Yeah, if you want to develop a multicopter for a specific purposes, are you may be suggested to learn the Arduino pilot, yeah, because it is very first it's very easy. I think not really easy, but I think it's good enough to learn, and the information about it is so complete. Yeah, so you can learn yourself. And this is the block diagram of standard multicopter. You have propulsion system, power system, and camera and gimbal. Gimbal is the mounting system that makes the camera steady. Yeah? And also you have a video transmitter here. And we divide it as the multi-rotor and ground control station. Yeah. So the ground control station has a video receiver, video monitor, and maybe you will use a ground control with a PC or mobile device that connected to telemetry transceiver, and you use a RC transmitter as well. So this is the environment how the multi-rotor works. And the software, yeah, if you want to have the software that cheap, and also it can be developed by yourself. It's free. It's a mission planner software. It's also from Ardo Pilot as well. Yeah. Ardo Pilot, this one, you can just type it on Google and you will find the Ardo Pilot website, and you can download the mission planner software. With this software, you can create a drone that can do some tasks autonomously, and maybe you can put some waypoint, or you want to create a drone sprayer that are following the path. Yeah, you can use it by mission planner. And in the end, what is a drone application in agriculture? There are so many actually application, but I only discuss two of them that really hype nowadays. It's a drone sprayer for agriculture. Yeah. So with drone sprayer, you can put some chemical on the crop plantation with a very efficient way. Spread, and with a spraying drone, it represents technological advancement in modern agriculture. Offering precise and efficient means of applying agriculture input to enhance crop protection and yield. With a GPS, digital mapping, and computer controlled spray mechanism enable these drones to optimize the application process, contributing to sustainable and effective management of agricultural resource. Because it is very efficient. If you are comparing it with the manual spraying, it will be faster, it will be more precise, and you can put that drone on the task in very fast. Yeah, for example, you have a target, for example, 1 acre, 2 acre, or 20 acre on 1 hour or 2 hour. Uh, it can realize that we can realize that by sprayer. And on the right, you can see what kind of the interface when you are creating waypoint on the crop plantation. And next is a drone for monitoring plant health. Uh, Drones equipped with the special imaging equipment called, maybe some called a multispectral imaging. Yeah. And we can get a NDVI, normalized difference vegetation index, from drone, because we use a detailed color information to put plant health. Yeah, for example, yeah, we can get a dead leaf, yeah, with this kind of spectral intensity, and stress leaf and healthy leaf. Yeah, we can distinguish them with the imagery, data imagery, and that is efficient if we are using a drone. So we can get the data and get the image data, and we put that on analysis. There are so many uh, software now that can analyze the NDVI data, and we can get the result that has a map that we can distinguish which one has a healthy leaf. Yeah, and we can distinguish them, and maybe we can put the specific dosage, put that on the spraying drone for precision farming. I think That's all the material that I could share. I hope it will be useful for you and see you again.